You've never been to heaven, have you?
Assalamualaikum warahmatullahi wabarakatuh.
Hello everyone.
First, let us start with introducing ourselves. My name is Andi Putri Ahira
My name is Denzel Sudjono
My name is Dayang Anisa Safitri.
My name is Audriana Septiani
from Heaven Group.
from Heaven Group.
From International Management Class, Faculty of Economics and Business Untan. I will explain about the first derivative of a function.
I want to explain about differentiation rule, the definition, the kind of differentiation rule, and the example question.
I'm in charge of explaining partial derivative, implicit function, and total differentials. Also, example question.
And here I'm in charge to explain about the practice questions of partial derivatives.
Derivative is the rate of change of a function with respect to a variable. Geometrically, the derivative of a function can be interpreted as the slope of the graph of the function, or more precisely as the slope of the tangent line at a point. Derivatives of function are computed using differential calculus. The first derivative of a function represents the rate of change of one variable with respect to another variables. We can use this concept for computing rate of dependency of one variable over the other. We may be able to find the derivative of a univariate function. The symbol of the first derivative is f(x) and x, or dy divided dx.
Now let's talk about derivative rule. There are 7 derivative rules that I want to explain, which consist of constant rule, power rule, constant multiple rule, constant divided rule, sum rule, product rule, and quotient rule. The first rule is constant rule. This rule states that the derivative of a constant function is 0. Since a constant function is a horizontal line, the slope or the rate of a change, so the constant is 0. If y equal to a, so dy per dx equal to 0. The example question, first, y equal to 10. So the answer is dy per dx equal to 0. If a is constant, so the answer is automatically is 0. The second example question, y equal to 6. So the answer is dy per dx equal to 0. Next, power rule. The derivative rule which n is constant and multiplied by the variable. Then the variable rise to the power minus by 1. The formula is dy per dx equal to n multiplied x power n minus 1. The example question, y equal to x power 4. So the answer is, first of all, we need to put the constant in front of the variable. So it is 4 multiple x power 4 minus 1. Yes, 4 minus 1 because the power is minus by 1. So the first derivative of y equal to x power 4 is 4x power 3. Third, constant multiple rule. Constant multiple rule is the rule which the constant multiplied by the first derivative function. Y equal to k times phi. So dy per dx equal to k multiple dv per dx. The example question is y equal to 5x power 3. First of all, we need to find the first derivative function of x power 3 is 3x power 2. Next, we multiply 5 and 3x power 2, and the result is 15x power 2. Next, constant divided rule is the rule which the constant multiplied by the first derivative function and divided by the square of the denominator. The formula is dy per dx equal minus k multiple dv per dx divided phi square. The example question is y equal to 7 divided x power 4. To find the answer, we need to find the k and the first derivative function of x power 4. The k is 7 and the first derivative function of x power 4 is 4x power 3. So the answer is dy per dx equal to minus 7 multiple 4x power 3 divided x power 4 power 2. So the answer of 7 divided x power 4 first derivative function is minus 28x power 3 divided x power 8. 5. Sum rule. If the function is sum or difference of two functions, then the derivative of the function is the sum or difference of the individual function. The sum formula is dy per dx equal to du per dx plus dv per dx. Then the difference formula is dy per dx equal to du per dx minus dv per dx. The example question is y equal to 6x plus 4x power 2. The answer is the first derivative of u is 6 and then the first derivative of v is 2 multiple 4x power 2 minus 1. So the first derivative of v is 8x. And then dy per dx is 6 plus 8x. And the answer is 6 plus 8x. 6. Product rule. The derivative of a product of two functions is the derivative of the first function times the second function plus the derivative of the second function times the first function. So the formula is dy per dx equal to u multiple dv per dx plus v multiple du per dx. The example question is y equal to open bracket 7x plus 2 close bracket open bracket 3x power 4 close bracket. So the answer is, first of all, we need to find the derivative of u. The derivative of u is 7 and the derivative of v is 4 multiple 3x power 4 minus 1. So the derivative of v is 12x power 3. Then we gonna answer the question. Dy per dx equal to u multiple dv per dx plus v multiple du per dx. So it is 7 open bracket 3x power 4 plus 12x power 3 open bracket 6x plus 2. Next, it is 20x power 4 plus 84x power 4 plus 24x power 3. And the final result is 105x power 4 plus 24x power 3. Next, quotient rule. The derivative of a quotient is equal to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. The formula is dy per dx equal to v multiple du per dx minus u multiple dv per dx divided v square. So the example question is y equal to 5x power 5 divided 3x power 2. First, we gonna find the derivative of u. The derivative of u is 5 multiple 5x power 5 minus 1. And the result is 25x power 4. Next, we find the derivative of v. It is 2 multiple 3x power 2 minus 1. And the result is 6x. To answer this question, the formula is dy per dx v multiple du per dx minus u multiple dv per dx divided v squared. So it is open bracket 3x power 2 multiple 25x power 4 close bracket and then minus open bracket 5x power 5 multiple 6x close bracket divided open bracket 3x power 2 close bracket power 2. And the result is 70x power 6 minus 30x power 6 divided 9x power 4. So the final result is 5x power 2.
Question number 1. Find the derivative of y equals x2. This uses the simple exponential rule of derivative. Y equals x to a, multiply by the value of the exponent to the function, then subtract 1 from the old exponent to make the new exponent. The formula is as follows: dy divided dx equals a multiply x to a minus 1. Using our function, y equals x to 2, where a equals 2 and a minus 1 equals 2 minus 1 equals 1. So we get the following derivative: dy divided dx equals 2x. Question number 2. Find the first derivative of the following form: fx equals 4x to 4 minus 2/3 x to 3 plus 3 second x to 2 minus 17x plus 43. In order to take the first derivative of the polynomial, all we need to know is how to apply the power rule to a simple term with an exponent. d divided dx multiply ax to n equals n ax to n minus 1. The formula above tells us that to take the derivative of a term with coefficient a and exponent n, we simply multiply the term by n and subtract 1 from n in the exponent. With this in mind, we'll take the derivative of the function in the problem term by term. So fx equals 4x to 4 minus 2/3 x to 3 plus 3 second x to 2 minus 17x plus 43. Fx and x equals 4 in the bracket 4x to 4 minus 1 minus 3 in the bracket 2/3 x to 3 minus 1 plus 2 in the bracket 3 second x to 2 minus 1 minus 1 in the bracket 17x to 1 minus 1 plus 0 multiply 43. So the first derivative of this form is fx and x equals 16 x to 3 minus 2x to 2 plus 3x minus 17. Question number 3. Find y-axis where y 4x to 5 plus 3x to 3 plus 6x to 2 plus 1. In order to find the derivative, we will need to use the power rule on each term. The power rule states fx equals x to n. Fx and x equals nx to n minus 1. Applying this rule, we get the following: y equals 4x to 5 plus 3x to 3 plus 6x to 2 plus 1. Y accents equals 4 multiplied 5 x 5 minus 1 plus 3 multiplied 3 x 3 minus 1 plus 6 multiplied 2 x 2 minus 1 plus 1 accent. Y accent equals 20x to 4 plus 9x to 2 plus 12x plus 0. So the first derivative of this form is y accent equals 20x to 4 plus 6x to 2 plus 12x. Question number 4. Find the first derivative of fx equals 7x to 2 plus 2x. For any function, fx equals a multiplied x to n. The first derivative fx and x equals nax to n minus 1. Therefore, taking each term of fx equals 7x to 2 plus 2x. Fx and x equals 2 multiplied in bracket 7x to 2 minus 1 plus 1 multiplied in the bracket 2x to 1 minus 1. So the first derivative of this term is fx and x equals 14x plus 2. Question number 5. Find the derivative fx equals 6x to 4 plus 2x to 3 minus x to 2 plus 5. The derivative of this function, known as fx and x, can be found by using the power rule of derivative on each term in the function. The formulas of power rule is x to n equals n multiply x to n minus 1. If there is a value in front of x, we multiply it by the n we carried over. For example, taking the derivative of 2x to 4 equals 8x to 3. Using the power rule, the first derivative of this form is fx and x equals 24x to 3 plus 6x to 2 minus 2x. Note that the derivative of any constant is simply 0.
So what is partial derivative? Partial derivative is defined as a derivative in which some variables are kept constant and the derivative of a function with respect to the other variables can be determined. So partial derivative are just like derivative, except that they're for multivariable functions where derivative are for single variables function. The symbol used to denote partial derivative is d, or some people also call it do. This d symbol is used to represent partial or partial derivatives. It represented as partial derivative of function f with respect to x, partial derivative of function f with respect to y, and partial derivative of function f with respect to z. Suppose we have a function f of x comma y which depends on two variables, which is x and y. X and y are independent of each other. Then we say that the function f partially depends on x and y. Now, if we differentiate function f with respect to y, then we treat x as a constant. And if we differentiate function f with respect to x, we treat y as a constant. So for example, z equals 2x squared minus 3xy plus 4y squared. We have to find the partial z with respect to x and partial z with respect to y. First, partial z with respect to x. Remember, if we looking for partial z with respect to x, we have to treat y as a constant. So the derivative of 2x squared is 2 times 2x squared minus 1, and the derivative of minus 3xy is minus times 1 times y. So the result is 4x minus 3y. And now we are looking for the partial z with respect to y. Remember, if we are looking with the respect to y, we have to treat x as the constant. So we just hop into the minus 3xy. I'm sorry, I did a little mistake here. I forgot to add the minus. The derivative of minus 3xy is minus 3x times 1, and the derivative of 4y squared is 2 times 4y squared minus 1. So the answer is minus 3x plus 8y. So partial z with respect to x equals to 4x minus 3y, and partial z with respect to y is minus 3x plus xy. Moving on to the total differentials. Total differentials of a function can mean the gradient of a function, which means the sum of all partial differentials with respect to all the independent variables. For example, if a function is z equals to f of x comma y, then the total differential of z is this. Amount of the term formed according to the number of independent variables, which is owned by the function. From the previous example, function z has 2 independent variables, so that the differential has 2 terms. The form can also be expanded according to the number of independent variables which is owned by the functions. For example, this. Example. Z equals to x cubed y plus x squared y squared plus xy cubed. Before we have to sum all the variables, we have to look for the partial z with respect to x and partial z with respect to y first. So partial z with respect to x is 3 times x cubed minus 1y plus 2x squared minus 1 and plus 1 times y cubed. So the result is 3x squared y plus 2x plus y cubed. And now partial z with respect to y equals to x cubed times 1, because the derivative of y is 1, plus 2 times x squared y squared minus 1 plus 3xy cubed minus 1. So the result is x cubed plus 2x squared y plus 3xy squared. So that we have partial z with respect to x is equals to this, and partial z with respect to y is equals to this. For the total differentials, we have to sum all the numbers that we have calculated. It became like this. So dz equals to partial z with respect to x dx plus partial z with respect to y dy equals to, we just have to insert the number here into the form. So equals to 3x squared y plus 2xy squared plus y cubed dx plus x cubed plus 2x squared y plus 3xy squared dy. Implicit function is a function with multiple variables. The differentiation of a function of one variable defined implicitly by relation f of x comma y equals to 0. So that function f of x comma y equals to 0, x and y expressed as an equation with the variables on one side and equalized to 0. An example of implicit function is an equation y squared plus xy equals to 0 is an implicit question. Also, a function f of x comma y comma z equals to 0 which the variables is dependent on the other two variables, is also implicit function. For the example, in this question we have to find the partial z with respect to x and partial z with respect to y, given 3x squared plus 4y squared minus 5z squared equals to 60. So because implicit function is equals to 0, we have to make the numbers is equals to 0 by moving the 60 to the left. So f of x comma y equals to 3x squared plus 4y squared minus 5z squared minus 60 equals to 0. And then now we can start to look for each variables. Start from fx. The derivative of 3x squared is 2 times 3x squared minus 1. Because we are looking for the x, we have to treat things other than x as constant. The result is 6x. And now we have to look for the, remember, things other than y, we treat it as constant. So the derivative of 4y squared is 2 times 4y squared minus 1. So the result is 8y. For the fz, we have to treat things other than z as constant. So the derivative of 5z squared is 2 times minus 5z squared minus 1. So the result is minus 10z. After that, we can start to look for the partial z with respect to x and partial z with respect to y. So partial z with respect to x is equal to minus fx equals to fz. So minus fx is minus 6x, because fx is 6x, divided by minus 10z. The result is 6x divided by 10z. You can simplify it and it will be 3x divided by 5z. Now for the partial z with respect to x equals to minus fy divided by fz. So minus fy is minus 8y minus 10z, because fz is minus 10z. So the result is 8y divided by 10z, and we can simplify it. It will be 4y divided by 5z. So partial z with respect to x equals to 3x divided by 5z, and partial z with respect to y is equals to 4y and 5z.
So for the first question, if function of x and y equals to y to the power of 4 times x to the power of 3, calculate df per dx of x and y. To find df per dx of x and y, we can see y as a fixed number and find the usual derivative with respect to x. It might be easier to let y equals to b, where b is a constant, to remind us that y as a number rather than variable. And then the partial derivative of df per dx of x and y is the same as the usual derivative of function g of x equals to b to the power of 4 times x to the power of 3. By using the rules of ordinary differentiation, we get dg per dx of x equals to 3b to the power of 4 times x to the power of 2. Then we can substitute back b to y, and we get the results, which is df per dx of x and y equals to 3y to the power of 4 times x to the power of 2. The second number is, if the function of x and y equals to y to the power of 3 times x to the power of 2, calculate df per dy of x and y. To find df per dy of x and y, we can calculate the derivative with respect to y. We can calculate this without using the substitution method. We only need to remember to treat x as a constant. We don't do anything to the x to the power of 2 and only derive the y to the power of 3 to get the results. So the result is df per dy of x and y equals to 3x to the power of 2 times y to the power of 2. Next is number 3. If the function of x and y equals to y to the power of 3 times x to the power of 3, calculate df per dx of 1 and 3. To find df per dx of 1 and 3, we have to find df per dx of x and y, which we can find the result as 3y to the power of 3 times x to the power of 2. For this partial derivative, x and y is equal to 1 and 3. So, we just need to substitute the respective value for x and y and get the result. So, df per dx of 1 and 3 equals to 3 times 3 to the power of 3 times 1 to the power of 2, which equals to 81. The next is number 4. Calculate the total differential coefficient of the function x to the power of 2 times y with respect to x, where x to the power of 2 plus x times y plus y to the power of 2 equals to 1. First, we use constant a equals to x to the power of 2 times y, where we have to find the total differential coefficient of a with respect to x, which is dA per dx. Then we have the total derivative of a, which is dA per dx equals to dA per dx plus dA per dy per dx. dA per dx equals to 2x times y plus x to the power of 2. Then we calculate the value of dy per dx by letting f equals to x to the power of 2 plus x times y plus y to the power of 2 equals to 1. Differentiating both sides with respect to x to get df per dx equals to 2x plus y plus x dy per dx plus 2y dy per dx equals to 0. So dy per dx equals to negative 2x plus y divided by x plus 2y. Therefore, dA per dx equals to 2x times y plus x to the power of 2 times negative 2x plus y per x plus 2y. dA per dx equals to 2xy minus x to the power of 2 times 2x plus y per x plus 2y. Number 5. If 3x to the power of 2 minus x to the power of 2 times y plus y to the power of 4 equals to 1, find the value of dy per dx. To find dy per dx, we need to do implicit differentiation, where we differentiate both sides of the equation with respect to x and treat y as an implicit function of x. So d per dx times 3x to the power of 2 negative x to the power of 2 times y plus y to the power of 4 equals to d per dx times 1, which we get 6x to the power of 2 minus 2xy plus x to the power of 2 dy per dx plus 4y to the power of 3 dy per dx equals to 0. And then we get 6x to the power of 2 negative 2xy minus x to the power of 2 dy per dx plus 4y to the power of 3 dy per dx equals to 0. After we complete the differentiation, we can isolate dy per dx by arranging the equation. dy per dx times 4y to the power of 3 minus x to the power of 2 equals to 2xy minus x minus 6x. dy per dx equals to 2xy minus 6x per 4y to the power of 3 minus x to the power of 2. Next is number 6. If 2x to the power of 3 plus x to the power of 2y plus y to the power of 2 equals to 4, find the value of dy per dx at the point minus 1 and 2. To find dy per dx, we need to do implicit differentiation, where we differentiate both sides of the equation with respect to x and treat y as an implicit function of x. dy per dx times 2x to the power of 3 minus x to the power of 2y plus y to the power of 2 equals d per dx times 4. Then we get 6x to the power of 2 plus 2xy plus x to the power of 2 dy per dx, and then plus 2y dy per dx equals to 0. 6x to the power of 2 minus xy minus x to the power of 2 dy per dx plus 2y dy per dx equals to 0. After we complete the differentiation, we can isolate dy per dx by arranging the equation. dy per dx times x to the power of 2 plus 2y equals to negative 6x to the power of 2 plus 2x times y, which we get dy per dx equals to negative 6x to the power of 2 plus 2xy per x to the power of 2 plus 2y. Then we can insert the point of minus 1 and 2 into the expression of dy per dx. And then we get dy per dx equals to negative 6 times negative 1 to the power of 2 plus 2 times negative 1 times 2 per negative 1 to the power of 2 plus 2 times 2. So dy per dx is negative 2 per 5. So we get the value of dy per dx at the point negative 1 and 2 is negative 2 per 5. Number 7. If 4x minus x to the power of 2y plus y to the power of 3 equals to 10, find the value of dy per dx at the point 1 and 2. To find dy per dx, we need to do implicit differentiation, where we differentiate both sides of the equation with respect to x and we treat y as an implicit function of x. d per dx times 4x minus x to the power of 9y plus y to the power of 3 equals to d per dx times 10. We get 4 plus 2xy plus x to the power of 2 dy per dx plus 3y to the power of 2 dy per dx equals to 0. For negative 2xy, negative x to the power of 2 dy per dx plus 3y to the power of 2 dy per dx equals to 0. After we complete the differentiation, we can isolate dy per dx by arranging the equation, which is dy per dx times 3y to the power of 2 minus x to the power of 2 equals to 2xy minus 4. dy per dx equals to 2xy minus 4 per 3y to the power of 2 negative x to the power of 2. Then we can insert the point 1 and 2 into the expression of dy per dx. dy per dx equals to 2 times 1 times 2 minus 4 per 3 times 2 to the power of 2 minus 1 to the power of 2, where we get dy per dx is 0 per 11, which equals to 0. So the value of dy per dx at the point 1 and 2 is 0.